Hello students, welcome to EPG Pathshala. I am Anup Kumar Kapoor from Department of Anthropology, University of Delhi. Today I am going to speak on the module Identification and Description of Fossil Caste from the paper Human Origin and Evolution. The learning outcomes of the modules are: first, to know about the caste of fossils; second, the identification and description of fossil castes. First of all, we will begin with the introduction of fossil caste. Evolution is confined almost entirely to the Miocene epoch from 23 to 5 million years ago, which probably covers most of the earlier history of the group. The first evidence for a diversification of the apes is in the early Miocene, and an origin of the group in the latest Oligocene or earliest Miocene seems likely. During the middle and the late Miocene, apes underwent an extensive phyletic and geographical radiation, expanding their range throughout the equatorial and sub-equatorial region of the Old World. Before the end of the Miocene, apes had become extinct over much of the area that they had once occupied. Ape lineages did persist into the Pleistocene, although some subsequently became extinct. All these surviving lineages were probably more widespread than they are today. However, their record after about 8 million years ago includes only scanty remains of Pleistocene gibbons and orangutans, dental remains of a recently extinct Pleistocene giant ape, that is Gigantopithecus, and Pliocene fossils of uncertain affinity, all from southern eastern Asia. The discovery of human remains more than 10,000 years old is always a cause for scientific celebration. Such finds are rare and valuable, as each new sample or technique may reveal threads of evidence in our understanding of human evolution. Consequently, there is a persistent requirement to measure, cast, and sample from existing and newly discovered human bones. The first figure depicts fossil records of human evolution, which shows how the different records has been represented and found by different anthropologists. Cast of fossils: cast, the positive replica of plaster, plastic, bronze, etc., made from a mold, and mold is the material, usually a type of rubber, that is brushed or poured over the original to make the negative. The cast may be made from the bone or a soft tissues. The important points about the original are: first, what is the material and conditions of your original? Note, it should be porous material, may be darkened by the molding process. Now the table 1 exhibits making of a fossil cast. The earliest material to use is plaster, which comes in any varieties. Some casting in material includes the following: common plaster of Paris is soft and easily scratched. High strength gypsum cements and dental plasters are harder, especially when mixed with hardener instead of water. Details on cast in these materials can be excellent, and shrinkage is minimum. Many plastics and epoxy are also available, but shrinkage of these materials, combined with their tendency to shorten mold lives. There are various techniques for coloring casts of all materials to bring out details. All involve a vehicle such as alcohol for dissolving and spreading artist pigments. Artist fixatives and spray lacquer add a long-lasting, appealing, and a protective finish to the final product, as reported by White in 2011. Identification and description of fossil caste. The fossil record shows a sequence from simple bacteria to more complicated organisms through time and provides the most compelling evidence for evolution. There are fossil casts from African, Asian and European hominids to study the process of evolution. Caniapithecus in Africa. Caniapithecus is found at sites that span most of the middle Miocene, such as Mabako, Fort Ternan and Nachola in the northern Kenya. Caniapithecus has derived facial and dental features that differ from those of the early Miocene genera and are more likely those of modern apes. The identifying features are: it has a thick layer of enamel on its molar teeth, very robust jaw, which indicate a shift in food preferences and habitat. His teeth and jaws certainly suggest powerful biting and prolonged chewing, perhaps on very hard and tough foods, a diet unlike that of any living primate. There was substantial sexual dimorphism in the canines and probably in body size. The recently discovered Otavipithecus from the late middle Miocene of Namibia represent the first record of Miocene apes from southern Africa. It is so far known from one specimen, a lower jaw, that unlike Caniapithecus appears to have restively thin enamel teeth. When we take Dryopithecus, somewhat later than the earliest Eurasian representative of apes, and thick enamel teeth, is Dryopithecus, sporadically known from Western and Central Europe. The distinctive features are: Dryopithecus has thin enamel teeth and probably had a diet different from that of the apes with thick enamel. The genus Ramapithecus, which historically important in the study of human evolution, was once thought to be present at some of these sites, as well as at the middle Miocene sites of Fort Ternan, Mabako and Pasala. But it is now clear that only distinguishing features of specimens attributed to this genus was their small size. These are probably females or small species of the genera at these various sites. Sivapithecus, the Swalic record of Sivapithecus favors the more recent of each reign, and none of these dates conflicts with the fossil evidence. Sivapithecus shares with the orangutan several features of the skull and face that are almost certainly derived within the Hominidae, and some of which are uniquely shared to the exclusion of other simian primates. These include the absence of a bony sinus in the burrow area of the skull, a very narrow bony partition between the eyes, vertically elongated orbits, and a set of features in the subnasal area that relates to the way the hard palate joins the premaxillary bone at the base of the nose, where the incisors are embedded, that is naso-alveolar sylvicus. Forelimbs of Sivapithecus are monkey-like, implying quadrupedal walking and climbing. Then we have Oropithecus. A virtually complete skeleton of Oropithecus has been unearthed. This is similar to modern apes in many features of the trunk and limbs. Oropithecus thus seemed to have more adapted for suspension than was other Sivapithecus or Rudopithecus. Now comes Ramapithecus. Ramapithecus was considered a possible human ancestor on the basis of the reconstructed jaw and dental characteristics of fragmentary fossils. The first Ramapithecus fossil, that is the fragments of an upper jaw and some teeth, were discovered in 1932 in fossil deposits in the Swalic Hills of northern India. Ramapithecus represented the first step in the evolutionary divergence of humans from the common hominid stock that produced modern apes and humans. Identifying features are: incisors and canines are smaller in relation to molar, absent or molar cups. Upper jaw is shortened and does not protrude forward but is long vertically. Palate is arched and wider from behind than the front. Face is short and deep, suggestive of not used teeth as weapon. He used hands for hunting and defense, that is, Ramapithecus was probably an erect biped with hands free. Now the picture shows fragments of upper teeth are Ramapithecus compared with the man and apes. The next stage is Australopithecines. Most fossil hominids back to 2 million years ago and perhaps just beyond are more closely related to modern humans than they are to chimpanzees and belong to our own genus Homo. The earlier part of the lineage has been allocated to several fossil species, of which Homo erectus and Homo habilis are the two best known. Compared with the African apes, most of all these forms of Homo have a relatively large brain, relatively reduced chewing or a molar, teeth and lip bones that are except in points of detail like those of modern Homo sapiens. However, there are at least 4 and perhaps 5 species of hominid that lack the expanded brain, the loose molar teeth and the skeleton features of Homo. They antedate or overlap with the earliest representative of Homo, are known collectively as Australopithecines. Species of Australopithecines. Types of Australopithecines. Australopithecines are conventionally split into 2 groups on the basis of their body types: gracile, more lightly built, and robust, more ruggedly built forms. The robust Australopithecines can be divided in at least 2 species of the genus Paranthropus robustus from southern Africa and Paranthropus bassai from East Africa. The name Australopithecus southern ape is then reserved for 2 gracile Australopithecine taxa, Africanus for southern Africa and Australopithecus afarensis from eastern Africa. Paranthropus is here used as a separate genus for the robust Australopithecines. Table depicts 2 schemes for tied nomenclature and taxonomy of Australopithecines. Australopithecines are classed as hominids rather than fungids because, like Homo, the features include reduced canine teeth and their limbs were substantially adapted for bipedal walking. However, the brains were relatively small and details of the brain features were different from those of later hominoids. Moreover, although Australopithecine limb bones could resist the loads and stresses of upright stance and locomotion, they did so without having the characteristic shape of the Homo pelvis and thigh bone, that is femur. The next figure depicts distinguishing traits of Australopithecines. History and context of the fossil discoveries. It is not easy identifying the features that mark the human genus Homo, as the group contains not just all living people but our closest fossil relatives as well. Moreover, many features that distinguish humans are behavioral and leave no fossil evidence. It is very difficult judging whether a particular kind of early human had developed a language, society, or art, and other features that can be recognized in fossils are usually used to infer these attributes. Southern Africa, Australopithecines, the first Australopithecine fossil was found in southern Africa in 1924 in a cave that was exposed at the Buxton Lime Works, which is close to Tongue, near Kimberley. The Tongue cave, like those at the other Australopithecine sites in southern Africa, was formed as expansions of water channels that ran through the limestone. Once the caves started forming, they developed openings onto the ground with surface through which soil and debris, including bone, was washed in. In Eastern Africa, Australopithecines fossils from Eastern Africa are found very different geological circumstances. The first fossil discovered at Garusi in Tanzania, a site that is now included in the Letoli site complex. More than 40 years elapsed between that first discovery and the re-exploration of the area by Mary Leakey, which resulted in the discovery of fossils that make up part of the collection attributes to Australopithecus afarensis, now considered to be a gracile Australopithecine species distinct from Africanus. 3 views predominate about the relationship between the Australopithecines and Homo. In the first scheme, Australopithecus afarensis is the common ancestor of two lineages, one leading to Homo, the other leading via Australopithecus africanus to Paranthropus robustus and Paranthropus basae. The second scheme also sees Australopithecus afarensis as ancestor to Africanus, but it has the latter as the common ancestor of the two lineages, one being Homo and the other leading to and including and the robust Australopithecines. A third scheme has fewer spores, but it may prove to be more durable than the others. In this arrangement, the Australopithecines and Homo share a common ancestor, which has not yet been found in the fossil record. Two lineages result from such an ancestor. One leads to the robust Australopithecines via afarensis, the other via africanus to Homo. These and other differences in our perception of hominid relationship, however, still owe as much to disagreement about methodology as to differences in interpretation of the fossils themselves. Early humans, a large brain has usually been the single most important feature, although on its own this may be an unreliable guide to membership of the genus Homo. In the early fossils, body size must also be taken into account to give an idea of relative brain size. If this were not done, some small-bodied and small-brained early humans might not qualify as human at all. Most members of the genus Homo do have a brain volume of more than 700 milliliters, considerably larger than that of the largest robust Australopithecines or living ape. To house a brain of such a size, the human cranial vault is large in relation to the face, and the face is tucked under the vault more than is the case in the early apes or hominids. Other diagnostic features on human includes the presence of prominent nose, as represented by raised bone surfaces around the nasal opening, and a bony spine at the center of the base of the nasal opening. These characteristics are further reflected in various measurements of the face. The base of the human skull is short and well flexed or folded up. Such distinctive features may be related to the development of language and remodeling of the throat to give a lower position for the voice box. The jaws of humans are also notable because the bone of the lower jaw is rather thin and there may be a vertical front to the jaw or even a bony prominence, a chin. The teeth, and in particular the last of the cheek teeth, are small. Tooth eruption is slow compared with that in apes and early hominids. Homo habilis, in the early 1960s, stone tools were found scattered among hominid bones close to the site where A. basae had been unearthed. Because of its association with tools, these early humans was called Homo habilis, meaning handyman. The distinct features are brain volume of about 680 cubic centimeters, larger than the Australopithecine rate of 400 to 550 cubic centimeters, small in stature with arms longer than legs. The figure depicts two hominid skulls of Homo habilis, which is very clear between how we find the differences. Next figure shows reconstruction of large and small Homo habilis skulls. Homo erectus was a lot larger than the Homo habilis, about 5.5 meters tall. It has a large brain, about 1000 cubic centimeters, and walked erect. Its skull had prominent brow ridges and, like modern humans, a rounded jaw. Then we had Java man. A Dutch doctor and an anatomist named Eugene Dubers unearthed a skull cap and a thigh bone in 1891. He informally called Java man for three reasons. The first, the structure of the thigh bone clearly indicated that the individual had long, straight legs and was an excellent walker. The second, the size of the skull cap suggested a very large brain, about 1000 cubic centimeters. Third, most surprisingly, the bones seem as much as 500,000 years old judged by other fossils Dubers unearthed with them. The figure depicts Homo erectus skull, which is very clear to understand. Homo neanderthalensis, that is Neanderthals and Homo neanderthalensis, lived in Europe and the Near East from 200,000 to 28,000 years ago. They were thick-boned with a large brain. They buried their dead and they made hunting too. This picture depicts reconstructed skulls of two Neanderthals showing distinguishing features. Now, modern humans. The first modern humans were anatomically distinct from Neanderthals with their less prominent brow ridges, higher, shorter and more rounded skulls, shorter lower jaw with a bony chin and less robust skeleton. They also had a hip bones, odd modern type, suggesting that the hip joints function like those of modern people. Three species of modern man are Cro-Magnon, Grimaldi and Chancelide. Cro-Magnon remains a representative of the earliest anatomically modern human beings. However, the skull of Cro-Magnon shows traits that are unique to modern humans, including the tall, rounded skull with near vertical forehead. A large brown ridge no longer tops the eye sockets and there is no prominent bruxism of the face and jaw. Grimaldi, the fossil remains were found in the village Grimaldi on the Mediterranean coastal region. Two skulls were found, that is, of a woman 30 years old and a boy 15 years old. The characters are mastoid processes are small and supraorbital ridges are feebly developed and the forehead is well developed. Large orbits with sub-rectangular shape and broad nose with low bridge were observed. Chin is poorly developed and teeth are large. Majorities of characters show affinities with the Negroid Chancelide man. Fossil remains were discovered in 1888 in a rock shelter at Chancelide, southern western France. The skull is long, narrow, measuring 19.4 cm length and 18.75 cm in breadth, and thus showing a cranial index of 70.9, that is dolichocephalic. The vault is high and supraorbital ridges are slightly marked. The forehead is almost vertical while the parietal tuberosities were well marked. The mastoid processes are fully developed. The Chancelide man resembles the modern Eskimo in the following characters: short stature, large, high dolichocephalism, head, elevated sagittal region, a very wide and long face, flat prominent cheekbones, narrow nasal aperture, powerful masticator apparatus. The table exhibits distinguishing features of early human species. The figure depicts fossil casts of early human species, and the other table depicts specimen of the Cro-Magnon, that is early modern humans. Let's summarize the module. The discovery of human remains more than 10,000 years old is always a cause for scientific celebration. Such finds are rare and valuable as each new sample or technique may reveal threads of evidence in our understanding of human evolution. Consequently, there is a persistent requirement to measure, cast and sample from existing and newly discovered human bones. Cast, the positive replica of plaster, plastic, bronze, etc. made from mold, and mold is the material, usually a type of rubber, that is brushed or poured over the original to make the negative. The cast may have made from the bone or soft tissues. The fossil record shows a sequence from simple bacteria to more complicated organisms through time and provides the most compelling evidence for evolution. There are fossil casts from Africa, Asian, and European hominids to study the evolution, that is Kenapithecus, Dryapithecus, Sivapithecus, Ramapithecus, Australopithecines, and early homins, which include Homo habilis, Homo erectus, and Homo neanderthalensis, and modern man. The modern men are Cro-Magnon, Grimaldi, and Chancelide. Thank you.